Hi guys, I'm Sriram.r studying in Sri Venkateswara College of Engineering. The subject is discrete mathematical structure, and the topic I am discussing is function composition. Function composition, an overview of a function composition and the inverse function. Introduction of function composition is this presentation explores the concepts of the function, the composition, and the inverse function, highlighting the definition, properties, and the application in the various fields. Function composition. Function composition refers to the process of combining the two functions to produce a new function. If f of x and g of x are two functions, the composition of these two functions are of f naught g x and f of g of x. This means that you first apply g to x and then apply to f to the result of the g. This operation is not commutative, meaning of the f naught gx does not necessarily equal to the g naught of f x. Understanding this concept is crucial in mathematics as it allows for the simplification and evaluation of the complex function relationships. And definition and the notations. Okay guys, the properties of the function compositions include the associativity, means the state of f naught g naught h x, uh, f of g naught of h multiplies with x and equals to the f naught of g multiplies with the h and also x. However, it is important to note the composition is not commutative as previously mentioned. Another property is identify the function where for an any function composition the identity function I results in the original function, such that f naught of I and x of f of x and I naught of f of x. This property facilitate and it is the manipulation and understanding the composed function in the various mathematical expression. As this guys, you are knowing that these properties are facilitate in the manipulations. Okay, and understand of composed function in various mathematical application and properties. Under the properties of the composition, under the function of composition, the properties are mentioned here. Applications in mathematical analysis, as we apply the function composition is extensively used in mathematical analysis. Analysis means analyzing the mathematical analysis to simplify the and evaluate the function. Simplify means shorter the way of executing the functions, and so in order to execute we should simplify. The complex expressions can often be expressed as a compositions of the simpler function, make it is easier analyze this behavior. For example, in calculus might compose a function to explore the limit derivatives and integral. Moreover, in the linear algebra, transformation can be represented in the via function and composition, enabling the clearer understanding of the relationship between the different mathematical constructs. Okay guys, understood. And the second one is inverse function. Inverse function, the inverse function definition and finding the inverse they have derived here. And inverse function essentially reverse the effect of the original function, means inverse means it will affect by reversing the original function. If f of x takes the input x and produce an output y, means they are taking input as x and produces output y, the inverse function denoted f inverse y takes that output and returns to the original input x. To find an inverse function, one typically swaps the x and y in the equation, solves for the y. Not all the functions have the inverse function. One as must be also, it should be having the bijective, meaning it has both injective one to one and surjective one to possess an inverse. Okay guys, and inverse function has several critical properties for a function f, and it inverse f inverse the following holds f of f inverse y. and y for every y in the range of f and f inverse by f of x for every x in the domain. This demonstrates the reversing nature of the functions. Additionally, if a function is represented as f of x for every x in the domain, this is the demonstrates the reversing natures of inverse function, as if it reverses the inverse function. Additionally, if the function is represented as f of x, then the inverse is expressed of f inverse x. Understanding these properties enables the mathematics solve the equation effectively transition the smoothly between a function and its inverse. And inverse functions are just a theoretical, they have the practical application in the various fields such as physics, engineering, and economics. For example, in physics, inverse you are used to determine the time from the speed distance. Economics, inverse demand. Moreover, in computing, the algorithm often rely in the concept of inverse of descriptive information. By applying this inverse function, professional can derive insight, make informed decision based on the data. Understanding this function composition inverse function crucial for navigating complex of mathematical landscape. Real world application. These concepts provide the functional knowledge essential for the various analytic and quantitative fields. By mastering this principle, one can enhance the problem skills, apply the mathematical reasoning effectively in diverse scenarios. Conclusions. Thank you, guys.